Hello, I'm Karthik Sundararaj, a technical lead with HCL. In this presentation, I'll illustrate an hybrid cloud analytics solution that we are developing for telecom service providers. This solution uses Cisco's container platform and Kubernetes service catalog to realize a hybrid distributed cloud application. This is the team behind the solution. In the presentation, I'll start with describing the business problem. Then we'll look into the solution requirements based on the problem and provide an overview on the hybrid cloud solution that we are trying to build, an overview of the prototype that we are building as a proof of concept, followed by the demo. Let's look into the business problem. Telecom service providers, as we know, serve millions of customers, and it is a challenge to monitor and ensure that customers have a satisfactory experience with the services. Service providers incur high operation costs through customer support and frequent truck rolls. Customer support is predominantly reactive. Customer reports the issue, service provider intervenes and remediates the issue. This causes customer dissatisfaction, resulting in churn and revenue loss. Service providers maintain large volume and variety of data across multiple systems, but is underutilized to add value to business. Different business units within the service provider organization work in silos, and this non-availability of integrated customer view leads to half-matured marketing efforts, unsatisfactory customer experience, and loss of business opportunities. Some of the common roadblocks from incorporating business improvements are lack of consolidated data and accurate insights, then extended cycle time to process data and delay in access to the insights. And there's heavy dependency on legacy systems to process the data. These problems are not new. Service providers have been coping with these problems for several years. We have tried to solve the problem in the past. Now we want to adopt a modern approach, incorporate the modern frameworks, the rich set of services that are offered on the cloud, and the advancements in the machine learning technologies. So some of the requirements, key service solution requirements are, first, aggregate data from a variety of data sources across different business silos and create a unified view of the business. And use the data and derive actionable insights into experience of customers with various services. Enable proactive detection of anomalies, issues, or any deterioration of quality, and help service providers remediate issues before customers report them. Predict the customers with propensity to churn and enable timely intervention to prevent revenue loss. Some of the key design considerations are as follows. Use container-based microservices architecture for flexibility and scalability. Use or adopt a hybrid cloud approach, again for flexibility to run services or workloads both on-premises and on public cloud. Service providers are keen on growing the resources on demand and not invest on infrastructure at the start. Enable seamless integration with cloud-based services for data aggregation, processing, and advanced machine learning implementation. So this is where the Kubernetes service catalog plays a critical role. So based on the above considerations, we use the following architecture components. The first component is the Cisco container platform to host these microservices and manage the lifecycle of these microservices. Then we use GCP's data flow for scalable stream and batch processing of data. We use BigQuery for descriptive analytics, and we use BigQuery ML for implementing simple predictive analytics. And we use Cloud ML Engine to implement advanced machine learning models such as deep neural networks, LSTM, GRU, and other complex network architectures built on top of TensorFlow framework. In summary, we are building a container-based hybrid cloud analytics solution that will help customers help service providers to understand their customers better. And it is intended to provide a unified view about the end customers and help improve the services and grow the business. So some of the salient features of the solution are, as I mentioned before, aggregate data from across a variety of data sources, blend the data, and then transform them into actionable insights. Track the customer's experience, track customers' footprints, and identify hotspots for cross or upsell. Provide forecasts into future trends, generate alerts, notifications, and enable service providers to perform proactive actions. So we wanted to first experience building hybrid cloud applications using Cisco's container platform and Kubernetes service catalog. So we decided to implement customer churn analysis and prediction as a prototype, as a proof of concept. And the scope of this prototype includes aggregation of data, because data is a critical part here. So first, aggregate data from different sources, which includes billing systems, customer support systems, service usage monitoring, CPE telemetry data, and so on. Then create an integrated view of the customer data and analyze churn. Implement a simple churn prediction model using hybrid cloud service. So we use the following tools and services: Cisco container platform for CI/CD as well as management of microservices lifecycle, PubSub for data aggregation, Data Lab for data exploration, Data Flow for stream and batch processing of data, and BigQuery for analysis and BigQuery ML for churn prediction. A critical aspect to the success of machine learning is the right selection of features. So with respect to customer churn prediction, we have identified all the relevant factors that influence the customer churn. It includes the frequent service disruptions that the customers have been experiencing in the past, how often they contact the customer support, what kind of an experience they have been getting from the customer support, then what the competitors are offering, and any billing discrepancies that they may have encountered in the past. So these are a few examples of the features that we use to arrive at the prediction. This slide provides a high-level solution architecture. So we have several services hosted on premises, and we exclusively use the cloud for implementing machine learning. So we have data sources, which are heterogeneous systems. We collect data from those using a collector microservice. The collector microservice does some level of cleanup and ensures that the data privacy is not violated, and it extracts the features of interest and publishes to the cloud. The collector service interacts with the cloud service seamlessly using the Kubernetes service catalog. Now, once the data is published onto the PubSub, then it is fed to data flow jobs, which do further processing, derive the features and the metrics, and then store the data in the BigQuery. This data residing in BigQuery is then consumed by a periodic machine learning job that trains the model, updates the model frequently, and then generates the forecast. Once the forecast is available, periodically the analytics service residing on premises will again use the service catalog and access the data store service on the cloud to download the forecast data and make it available for UI. The UI microservice will consume both the historical data as well as the forecast data and help the service providers analyze the churn and predict churn. This slide presents the data pipeline or the data flow within the system. So the data gets published. There is some pre-processing before the data gets published onto the cloud PubSub. The data gets processed on cloud data flow. Then it gets stored in BigQuery, picked up by the machine learning job. The model is built, forecasts are generated, and the data returns back to on-premises for consumption. For development of the services, We leverage the CI/CD mechanism offered by the Cisco Container Platform. So this shows the typical CI/CD pipeline that we use for our development and delivery of the solution. Now let's look into the demo of a prototype.
Hi, good morning all. This is Venu from HCL. I am going to show a demo on Media and Telecom Customers Churn Prediction for Cisco and Google Cloud Challenge. As part of this demo, I will showcase CCP, GCP, and the UA application integration. To begin with, we'll start with Cisco Container Platform. I am now logged into CCP. From here, I will launch Kubernetes dashboard. Here we have a Kubernetes dashboard which displays deployments, jobs, etc. We will now see the services that are created in Kubernetes platform. Here you can see PubSub app. We have created it as node port to export it as service. This service will be invoked internally in periodic manner through a batch job, which will post the media telecom customers data to GCP PubSub. The next important service that we have created is for CCP BigQuery data retrieval. The last major service we have created is for the UA application to showcase the customer data. We have also created MySQL database service in Kubernetes platform for storing the churn data and the telecom customers raw data. The entire service deployment is automated through CCP CI/CD platform as depicted, which contains both Git repo and drone CI/CD. This will Dockerize the application image and pushes Docker Hub and GCP container registry. Let us now see how the data flows from CCP to GCP. The batch job that is created on CCP periodically takes the customer data and pushes it into local MySQL as caching and also posts it into PubSub for ML process. In the application console, we can see that the data posted by batch job to the PubSub. Let us now see in GCP how the data from PubSub to BigQuery is posted. For sending data from PubSub to BigQuery is accomplished by data flow job template. We can see the running job details. Let us now scroll down and see input topic. Topic which we are using is PubSub app CCP. And output table spec, we are using churn table dataset underscore demo. Let us now search for the customer ID in the BigQuery to verify that the data has indeed received. Let us choose a customer ID. Copy it and use it for the query. If we run the query now, we could see that the query result has given the customer ID. This shows that the data has indeed received to the GCP. Now let us see the status of service catalog installed on the master node of the CCP cluster has bound our on-premise services to Google GCE Service Broker for enabling true hybrid cloud use cases. The commands that we will execute are cluster service broker, cluster service classes, cluster service plans. And get binding. That is the binding of GCP service. From the output of bindings, we can see that the services like BigQuery, PubSub, and IAM for roles for GCP Services Broker are enabled. We have seen how the data has arrived at the GCP. Now we will begin the data model building process. Initially, the data will be a training data set would be sent from the CCP to the GCP. That one we will explore using the data lab for making the necessary changes to the data, like scaling the features and removing any missing values. We'll also explore the correlation and post the data back to the BigQuery for ML modeling. Here, if we see, following are the features, and we will do the missing values, changes to the missing values, and we'll also see the correlation as explained. And we'll also see the features which are dependent on churn, how they impact it, and finally we will post this data, modified data, to the BigQuery. In the BigQuery, we have the SQL sort of query that we have built in for the running the logistic regression, and the model is built. Once this model is built, we will periodically be getting the data from the CCP for populating the period table. That table will be populated with the customer data who are likely to be churned out. So the model, we have seen how the model is built, and we'll also have seen the final POC, the final query that we will use to populate the period table for predicting the customer churn. So that is what we will do in the analytics portion. After ML process, we are retrieving the data periodically from churn PRED table _ table in the BigQuery through the service broker in the CCP. This data is also persisted in local database. In this window, we can see the BigQuery application console log. Data is also shared to UI through REST API. Let us now see the UI interface for the application. Here, we have categorized the churn data by region, service, and reason. We can also see the overall churn in US and the predicted revenue loss. In the forecast screen, we can see the forecasted churn based on region, service, and reason. Customer reported issues and the services currently used by them can also be seen here. This data can also be used to take quick action by the service providers and thus can prevent the customer churn.